Welcome to CorporateFinanceHQ.com. This is Jeff. I'll be giving you a lesson in the series of risk return and the capital asset pricing model. I'll be computing sample parameters, and these sample parameters will be the realized rate of return, the average rate of return, and the sample standard deviation and the variance. So the realized rate of return is equal to R hat sub t. The average rate of return is equal to R hat, and that is equal to the sum from t equals 1 to n R hat sub t divided by n. The sample standard deviation is equal to small sigma capital S, and that's equal to the square root of the sum from t equals 1 to n R hat sub t minus R hat squared divided by n minus 1. And the variance, of course, is the standard deviation squared. So our problem today is calculate the parameters R hat sub t, R hat, and S from a stream of monthly returns on the S&P 500 index, GSPC, reported in Figure 1. So how are we going to do this? So R hat, we'll start with R hat. R hat is equal to the sum from t equals 1 to n R hat sub t divided by n. Okay, so here, starting with t equals 1, time period 1, then it goes to time period 23, and our n starts from 0 and goes to 23. So we'll take these numbers in this column and do nothing more than sum them across each row as I have identified here. So you see the negative 2.77, negative 2.77, negative 6.44, negative 6.44, etc. So we'll go all the way across, and then we'll divide by n, and our n is 23. And if we do the math, we get negative 12.98% divided by 23 is equal to negative 0.56%. And this is the same as we have here, calculated from the Excel spreadsheet. Our sample standard deviation, all we're doing here is we're taking the square root of the sum from t equals 1 to n R hat sub t minus R hat squared, and we're just taking these numbers. We're taking the first number here, negative 2.77, and we're subtracting it from R hat, which is negative 0.56, which we see down here on the end of this column. And we're just squaring each one of these on an iterative basis all the way across these numbers again. Until we get to here. And then we're divided by n minus 1. N again is 23, so 23 minus 1. Do the math. These sum up to 5.51%. 23 minus 1 is 22, and this is equal to 5%. And this is what I have here. To find the variance, S squared, 5% squared, 0.25%, 0.25%. Again, this 5.51% is the same as right here. So these are, if you just sum these up, R hat sub t minus R hat squared, sum these squares up, you'll obtain the same answer. I wanted to also tell you how I derived this negative 2.77. It's nothing more than taking 1073.87, subtracting it from 1104.49, and dividing it by 1073.87 multiplied times